If you maintain industrial equipment, you know the frustration of replacing the exact same bearing 3 times in 6 months. The equipment keeps breaking, the downtime keeps stacking up, and the team is stuck fixing the same symptom without ever finding the root cause. We are going to take that vague operational headache, the sense that a process is simply broken, and turn it into a precise, actionable map of hidden bottlenecks using the SIPOC framework. Grab a piece of paper or SIPOC tool whiteboard, block out 60 to 90 minutes with your team, and pick one specific recurring daily headache to focus on. Together, we will untangle those overlapping problems into a structured linear path forward. A problem with a properly defined scope is already half solved. Establishing the boundary of the issue before investigating is the most important step in eliminating it. In lean methodology, waste refers specifically to any measurable process defect. This downtime chart details 8 categories of hidden process waste: defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and excess processing. Categorizing a frustration into one of these specific wastes upgrades the problem into a targeted defect ready for elimination. This 5-column SIPOC framework requires starting in the exact middle, the process column. Write down exactly 4 to 7 high-level steps, not 20 microsteps. Anchoring the center column establishes strict boundaries, preventing the investigation's scope from spiraling out of control. Next, move right to define outputs and customers. Detail exactly what each step produces with precision, then name the exact customer who receives it. An output without a customer is overproduction waste. A customer without a specification means you cannot identify a defect. Now shift to the far left to define inputs and suppliers. For each process step, list the specific materials, information, or energy required. Then, strictly name the exact supplier handing that input over to you. Often, a mechanical breakdown is an upstream input defect. That destroyed bearing might have failed simply because the storeroom dispensed contaminated lubricant. Mapping the left side allows the team to look past the equipment failure and see if the inputs provided by suppliers were actually compliant. As a final check, read your completed board hunting for downtime wastes. Scrutinize inputs for materials lacking incoming verification. Scrutinize outputs for products lacking measurable customer specifications. Every unverified handoff or missing specification is a confirmed defect, ready to be logged into your defect register. You have now taken a chaotic operational headache and mapped it into a tightly bounded 5-column diagnostic tool. Creating the diagram is not the final goal. The value is the clarity it gives you to strike at the root of the problem. Take your newly identified list of input and output defects back to your team and begin formal root cause analysis. True continuous improvement requires you to stop the endless cycle of firefighting, define the scope of the work, and eliminate defects at their actual source.